Hey, I'm going to show you 5 basic commands for drawing pictures with a turtle on the screen. This is going to be our first lesson in how to write a program with TurtleBits. So you just go to turtlebits.net and click on Let's Play, and you get to our beginner screen, which has a built-in program on the left-hand side, and on the right-hand side is a sandbox where the turtle can move around and do its drawing. Right in the middle is a big play button, which is what we press if we want to actually tell the turtle to follow the program on the left-hand side, which we're not going to do yet because I'm going to show you the 4 basic commands. In fact, we're going to delete this program and we're just going to work in the right-hand side. What we've got here down on the bottom is the command window, and that's an area where if we type commands, the turtle will run them right away. First thing we're going to do is pick a color to use. My favorite color is red, so we can say pen red. Now, that has to be typed exactly like that. The word pen is called a function, and the turtle has a bunch of functions that it understands, and red is one of the colors it knows. If you type it wrong or you type something that the turtle doesn't understand, it'll just tell you. So, um, it like has no idea what chartreuse is. If I say pen chartreuse, it'll say chartreuse is not defined. It'll say that in red, so you know it's an error. And it's not a big deal. We can just pick a color that the turtle actually knows, red or blue or orange. There's 140 colors the turtle does know, so you can pick pink or brown or whatever color is your favorite, and we'll do the drawing in that. The first thing that we're going to learn how to do is how to move the turtle forward. The function for moving the turtle forward is called FD. That just stands for forward, and it can move the turtle by any number of steps. We'll tell it to move 50 little steps, which is 50 pixels. Pixels are tiny little dots, which are the smallest type of dot that the computer can put on the screen. And so so 50 pixels is actually not that far. Each one of these grid squares is 25 dots apart from the next, and it drew a red line 2 grid squares long. Now, to make an angle, we can turn the turtle. LT turns the turtle left by some number of degrees. LT 90 will pivot the turtle left. Now, the thing to notice here, the function comes first, and so our 3 functions we've used so far are pen, FD, and LT, and each one takes a single argument. The first one was a color, and the other 2 are just numbers. And it's really important to put a space between the function and the argument, and it's also important to spell things exactly right, including the case. So you shouldn't have uppercase letters for any of these things. In this language, uppercase is different from lowercase. We can actually type any number that we feel like. If we said FD10, it'll just move by a small amount, less than half of a grid square, 10 little pixels. And the other thing that we can do is we can actually turn the turtle right, not just left. There's another command for doing that that's called RT for right turn, and I'm going to tell it to turn right by 120 degrees here, which turns the turtle sharply all the way up here. And I'm going to move the turtle forward so you can see what direction it's going in. There we go. And remember, left turn is what you do to turn the turtle left, and right turn is what you do to turn the turtle right. Everything is just 2-letter commands just to make them easy to type. So the other command, the 4th command for moving the turtle, is just to back the turtle up by saying BK. That stands for back or backward. I'll back the turtle up by 80 pixels, and we can see the turtle sliding back here. So to review, we've got left turn, LT, we've got forward, FD, we've got right turn, RT, and we've got backwards, that's BK. And each one of those things moves the turtle a different way. We can combine those things while we're dragging a pen to draw nice pictures. Actually, we've ended up with a good picture of a house or an arrow or something. It's pretty pleasant. So we can actually save this program by selecting it all. I'm using the mouse here to select the commands that I type that I like, and I can just drag and drop these into the left-hand side. A simple program like this is called a script because the computer will perform them just like reading lines in a play, just from top to bottom. If I press play here, then I can see the turtle do all these actions without me having to type them one at a time. And that's pretty powerful. I can do that and save that away, and that's my program. So this isn't saved yet. I have to press the save button here and pick a username that I'm going to save under. You should be creative and pick your favorite clever name. Doesn't need to be your own real name. It can be just anything that you think is memorable. And here, you can optionally put a password on the account, and what it'll do is it will create a new domain name, a new website, just for you with the name that you've chosen under the TurtleBits domain. And when I hit OK, the whole thing will be created, and my program will be moved into my own space under turtlebits.net, and I can just run it here, and I can always come back to this spot and run it again. If I hit refresh or whatever, my program will be saved, and it'll be here to run anytime I want. I can pick a new name for it by just clicking on this, and I'll call this house, I guess. Oh, it's asking me to log in again. That's fine. And now it's called house. There we go. Now, isn't that fun? After you run your program a few times, you'll realize that you sometimes want to actually make it go faster than it does by default. So let's go ahead and do that. If I say speed 10 here, it'll go 10 times faster than normal. And I can actually see a speed 100 to go even faster than that. Or speed infinity. Let's save that. And if I clear the screen, and if I run it at speed infinity, you can see it just basically draws instantly. That's as fast as the computer will go. And the next thing we'll play with angles, so you can see exactly what's going on with angles. Okay, let's take a quick look at some angles. Okay, so we finished saving our house in our new account, or whatever our shape was that we wanted to make. And if we want to do a new experiment, we can click on this button up here, which goes to the top directory of our website, and click on this button, create new file, which will create a new file for us. It initially be untitled, but we can give it any name we want. I'll just call this shape for now because we're not quite sure what the shape will be, and we'll draw it here. So let's pick a color. Blue is a nice color. And what I'm going to do is I'm going to draw a square, which has 4 sides and it has 4 angles like this. So we move forward 100, then we're going to turn right by 90 degrees, forward 100, right turn, forward, right turn, forward. And you can see it go here. It's exactly as expected. 4 corners to a square, each one 90 degrees. Now, how would we make a triangle? This will actually not work. What I'm doing here is just not going to quite work. I'm going to do the same thing. I'm going to change all the angles to 60 degrees. Now, if you know what an equilateral triangle looks like, you'll think it has 60-degree angles. And if I play this, you think, well, maybe it'll make a triangle, but actually it doesn't. Take a look at what it's doing. It's making the beginnings of a hexagon. If I actually copy this a couple more times, I'll have a perfect hexagon. You can see what it's doing here. Now, when I tell the turtle to turn right by 60 degrees, it's not actually tracing out a 60-degree angle. What it's doing is it's changing its bearing, changing its direction by 60 degrees. And so it's making actually making an obtuse angle. I have a little demonstration of that here on this page. Let's take a look at this. So this is a diagram of the path that the turtle will take in red. And when you tell the turtle to turn right by 90 degrees, it's changing its heading, it's changing its direction from straight by 90 degrees to over here. If we tell the turtle to move just by 1 degree, then it's not going to turn so much. I can do that by just bringing this all the way down So it's my little demo thing. You can see a 1-degree turn is just a tiny little change in direction, and it hardly makes an angle at all. But as the number of degrees that I'm going to turn by increases, then the direction changes uh, more abruptly, and we're going to make a sharper and sharper angle. So a very slight turn will actually make an obtuse angle, and then we actually have to make a very large turn to make an acute angle. So if we want to make a 60-degree turn, we actually have to make an angle that looks something like this. Now, mathematicians call this angle here an exterior angle, like an exterior angle of a polygon, because it's on the outside, and what you traditionally measure in geometry class is the interior angle. But exterior angles are pretty useful when you're talking about change in direction. So that's the way that turtles do their drawing. If we wanted to actually make an equilateral triangle, we'd have to make 3 60-degree angles, we'd have to draw 3 120-degree angles. Exterior angles plus interior angles always add up to 180 degrees. So let's go ahead and do that. So let's go back to our program here. Instead of 60, we're going to say 120, and we're only going to need 3 of these. And I don't need the rest of this. We'll delete that. We'll pick a nice color, and we'll draw it. And there we have our nice purple colored triangle. Isn't that beautiful? Now I'll show you a secret here. If I add a comma after the color and pick another number, I can actually make my pen nice and thick. So here we're selecting a purple pen with thickness 5. The comma separates the first argument from the second argument. So I've put in an optional second argument here. Make a nice fat pen. Here, let's make it even fatter. Got a nice triangle. And that's an explanation of angles. Okay, I'm going to show you a few more things: how to draw circles and curves, and draw text on the screen too. So let's go back to our account. So I picked a newbie account called newbie.turtlebits.net. If I go there, then I can see this other program that I saved, but it's not in edit mode right now. If I just click on that, it'll just run the program. So if I click on this edit button, it'll enter edit mode, and that'll let me log in and create new files and so on. So here, let me log in, and we can create a file, and I'll call this one bow or something. And what we're going to do is go ahead and edit a program in here. So if you remember, the basic command for moving a turtle is forward, FD 100. So now, a question that a lot of people ask is, how do you actually make a curve? If we wanted to make a circular arc, if we wanted to take the turtle and move it in a curve, what do we do? So what we actually have here is we can actually tell the turtle to turn right, but not pivot on a point, but turn right with a turning radius. Kind of like a car doesn't pivot in place, but it actually has to move in an arc when it turns. And so the second argument for right turn is a turning radius. To pass 2 arguments to a function, you have to put a comma, and then you can put the other number or the other argument after the comma. So this will turn right by 90 degrees with a turning radius of 50. 50 is 2 grid squares here, so what I'm expecting to see is the turtle to actually sweep out an arc and end up here at this spot. Let's see if it does that. That's perfect. And so you can actually make a complete circle by saying right turn 360, and it'll make a circle. If I want to make a half circle, I can say right turn 180. Let's do that here. Right turn 180, comma 50, and it'll make this nice pattern. And let's see, we can also do obviously with left turn. So if I say left turn 270, 50, then it'll complete this little infinity loop, which is a nice pattern. And I'm going to move back to the center of the infinity loop, and I'll show you another thing that we can do. So the other way of drawing a circle is just to have the turtle draw a dot. And dots are pretty useful for debugging because they don't move the turtle at all. So they don't otherwise change the state of the program, but you can see where the turtle is. So if we say dot, we can give it a color, and it'll draw just a little dot with that color. Or if we give it the optional second argument, it'll draw a nice big dot. So there's our gold dot. The other thing that we can do to label a spot without moving the turtle is to leave a text label. So let's see. So text is different from colors and numbers because I actually have to put text in quotes. The idea here is that we're not going to label with something called hello. We're actually going to label with the actual text, HELLO. So let's do that. There's our string. Move our turtle out of the way so we can see the nice effect. And what I'm going to do is make this here the program. And we'll clean it up a little bit. Run this here. You can see how this all hangs together. We'll make this a little faster. And we'll save it. That's our program.